Hello, and welcome back to another episode of Valory's AI Frontier series, where we bring you conversations with the people currently working at the far edges of artificial intelligence. As the premier creator of open source frameworks for co-owned AI, Valory's mission is to empower communities, organizations, and even countries to co-own the AI systems of the future. We created this series to collect and share a broad range of perspectives from people currently working with AI agents. One of those people is today's guest, Silen Naihin. Silen has been making great progress with AI agents. First as a founding engineer of AutoGPT, and most recently with his own company StackwiseAI. His experience in the field, and first-hand insights into artificial intelligence more generally, made for a very interesting conversation that I think you're really going to enjoy. So, here's my conversation with Silen Naihin. Okay, so welcome to AI Frontiers, and we'll start having you tell us your name and what you've been doing lately.
Hey, I'm Silen. I do whatever interests me, and that happens to be the field of AI and AI agents right now.
Awesome. Well, thank you very much for making the time to do this. I think it should be very interesting, and I'm looking forward to hearing about how AI agents are incorporated into your work. So I'll get straight into it with the definition of terms. How do you define an AI agent?
I would say my definition probably encompasses more things than most people. I would just say anything that you can chat to through natural language and does actions and then reacts to those actions. So honestly, code interpreter, I would consider an agent in some way. Same with like the browsing feature of ChatGPT. So yeah, anything with natural language input and performs some actions that aren't just text.
Right. Okay. Yeah, that makes sense to me. Maybe we could get into like a definition of terms. Could you give me an example of something that you would consider an AI agent and then contrast it with something that you wouldn't consider an AI agent?
I mean, the line to me would be the difference between a chatbot and then something that then goes and like browses or writes code or executes things. And I say a line, but it's also a spectrum, right?
Hmm.
Like on one end, you have something like just a program, like a code program that you execute and it compiles and it runs, and that's on one side of the spectrum. On the other side of the spectrum, you have something like AutoGPT, for example, which just executes actions, and the main medium, there's always actions. So you give it a high level goal and it executes actions. And then something kind of closer towards the middle that I would still consider an agent would be code interpreter or find. If you used find before, they like search up and find links, and they do rag. Rag in some ways is like you're not processing what kind of things you need to retrieve, but you are still retrieving. So I'd still put that I put that in the non-agent side. But yeah,
Okay, so there's a bit of a spectrum here, and you're including things like on the edge of that spectrum, like code interpretation. What makes that similar enough that you would put it on the spectrum of agents?
it's the fact that it is reactive. It can perform something and then perceive. I think that that perception piece is a fundamental part of agents, where you are doing something, you're affecting the environment in some way, and you are able to respond to that output in some way towards a higher level goal. Like if we look at before agents were taken over by the language model world, they existed in the reinforcement learning world. And in reinforcement learning, an agent was by definition something that had a certain reward function, collect dots or find the other player or whatever else it would be. And then it would, based on its current environment, perform a certain action. And then based on that action, its environment would change, and then it would perform a new action in order to reach its goal. And so it's very similar in this way with AI agents or with language model agents, where the more you're perceiving, taking a step, and then doing another thing, and then perceiving it again, this kind of loop where you have a higher level goal, like, anything from, book me an Uber to, write this entire code base for me, like there's different levels of depth, but you, at every step, like writing code, you're stopping, you're compiling, you're like, based on the result, there's an error. You're like, all right, let me change this or write some new code. And you kind of have this like perception action process, essentially.
Okay, that makes sense. Maybe we could talk a little bit about your background. Could you tell me how you got into the field of AI and if you had any moments where things really clicked or you felt like, wow, this is something really amazing?
Yeah, I mean, I've always been big fan of AI. I think it's very obvious from very early on that this was like, all the way from Ray Kurzweil's like the singularity is here, all this other stuff. Like AI was going to be like whenever I would think about how do you solve all the problems, and it's like a very grandiose thing to say, but like how do you solve all the problems? It's like I saw a tweet the other day about this as well. It's like solve climate change, solve all this other stuff, health, all this other. If you build an AI that is sufficiently on the side of an oracle, or can essentially tell you things and explain how it got to those conclusions. Obviously, we're not there yet, or close to being there, but it would solve a lot of these other problems. And so this was where my initial interest was. But I started more kind of in the world of something else. I did quantum computing for a little bit, and then I started a company in the creator space doing data analytics. And I ended up joining, instead of continuing with the creator space, I moved more to the data side and ended up joining as founding engineer at an AI company where we were basically doing like agentic stuff before agents were a thing. We were like basically doing Copilot for spreadsheets where, you'd fill in two leads and then you'd click tab and the other 50 leads that would have some sort of matching criteria would be filled out. And that was kind of closer to the web kind of scraping side. And then after that, I did some exploring. I mean, later last year, I was looking into alternative architectures to transformers, like Numenta and Jeff Hawkins stuff, and there's been a lot of exciting stuff this year about Hyena and LongNet and some other great architectures, alternative architectures to transformers. But earlier this year, after I wrapped up a contract at Delphi AI, which is a cloning platform, I was a little bit depressed, I'm not gonna lie, because I was like excited about AI and like, hey, like we got quantum computing, we need to have the compute for AI to be possible, we need to come up with an architecture that's more efficient and can reach this better. But then GPT-4 dropped, and it was kind of like this click in my head where I was like, maybe you see more compute, and that's it. At least to reach that point where you have this like quote unquote boom, where like it starts improving itself. And so I thought about it for a few weeks. I got a little, I did a dopamine fast to get myself out of it. Ended up on the other side being like, hey, there's still a lot of stuff to do. And there's still so many cool applications, even with AI, like sure, AI being solved or AI scaling compute, that doesn't mean like you still need ways to bring it to people. Like ChatGPT is like 100 million users as a splash in the ocean compared to the entirety of humanity. So there's still a lot of problems to solve, and there's a lot of ways to use AI. And at the time, AutoGPT was blowing up, and I had a similar idea back in December when I was thinking about alternative architectures, and I was like, hey, this is a great project. Let me start contributing and helping out, and have some domain expertise here. Eventually, I was chosen as the R&D lead, which is open source. It's cool, but with my now co-founder Wayne, we were like, we got to do benchmarking. This is because at AutoGPT it stagnated for a little bit. We were getting pull requests from all different kind of corners, pulling the project in a lot of different directions, and we didn't really have a good way to test them. Like we kind of just had to take these pull requests at face value and merge them or not merge them, because we didn't have the time to test it. And so we made kind of an automating evaluation benchmark for this for agents, and had some of the largest or all the largest open source agents kind of integrated into it, and ended up writing a paper at AutoGPT about kind of AI safety testing and misalignment, and eventually ended up joining as a founding AI engineer at AutoGPT, and as of about a month and a half ago, left to start my own company.
Okay, that's a really interesting journey, and you touched a little bit on another question that I wanted to ask you, which is about where you started working with AI agents. It sounds like you were already interested in that direction with the Copilot for spreadsheets. Is that right?
Kind of, yeah. There was no like spark. It was just kind of like, this is like we all thought about like AI is going to do these things for us, and like if it thinks it can do certain things, but I think people underestimated how quick language models would rise. Like I certainly did. I was very surprised when even 3.5 came out, and also what level of capabilities it unlocked. So before this whole rise of language models, AI was not as mendable, maybe that's the right word, but it wasn't. It was more rigid. It was much more artificial narrow. Like it was like you trained an AI for a specific purpose. Like this was
Right.
like something trained on a certain data set for this thing, right? But after this whole prompting paradigm, which is like insane, it not only allowed much more people to use it, but it also allowed for quicker development cycles, and for a much broader amount of use cases. And so essentially with these language models, you could use them as a brain to like mimic thought, right? Or depending on what your thoughts are, whether it's mimicking or it actually is thought. But yes, it would reason. And so then you have this like, okay, now I can attach this reasoning to actually doing things, right? All humans do are reasoning machines that then do things. And then we have a person, like we are agents, right? We are just agents. We're very, very advanced agents, but we're just agents. And when Torin came up with AutoGPT, it was like, damn, like this is really possible now. And it never was before. It's very exciting.
Yeah, that's been a very interesting thought technology for me as well to think of how much my own behavior is agenting and that there are some really clear parallels. I'd love to hear a little bit more about what you're doing with StackwiseAI right now and how you're incorporating agents into it.
Yeah, so Stackwise at a very high level, and I promise I'll get more real in a second, but at a very high level, I think with the realization that AI is going to change our lives much quicker in a much more drastic way than I thought, my focus has shifted to how we incorporate it into our lives in a meaningful way, in a way that helps us, right? There's people that always say, like, oh, it's just going to augment people, it's not going to replace them. But what do you think happens when a company can augment one of their engineers 10x? Like, do they need those other 9 engineers now? Or right? Like, obviously, it's not one to one, and it's a very crude kind of approximation here. Other jobs will always open, so overall, it's net positive. You also have to think about like what happens, and this is a long-winded answer, but there's this kind of whole thing of like, okay, like once AI is smart enough, does it then not enslave us, but it's just like we just don't understand how to work with it. It's almost like just making things happen, and then humans just go into basically like a Wall-E like world where we're in a utopia by all accounts, but it's a very hedonistic utopia, and it doesn't make people happy. Like TikTok, like Twitter. I mean, Twitter's a little different. I'm almost a little biased towards Twitter, but we have to find a way to merge more with AI. And so I'm thinking about how do you build this kind of layer to merge with AI. And so to get more practical with it, that means being able to create actions. That was very grandiose, and that's just kind of a more kind of general thought that I'm thinking about. In terms of specifically Stackwise, we're thinking more about how do you leverage kind of integrations and turn them into actions, so that in the short term, you can essentially have a bunch of boilerplates or pieces of code that you can then repurpose for different things and generate things from. So, for example, like if you want to, stream using Vercel's edge function, that took us an hour to set up, but now you have that boilerplate where you can just go and try it out. Essentially, semantic search for any function that you would need, and these are all actions, right? And if you can perform actions really well, then in the future, you can just perform actions through natural language, which is just kind of agents. Agents is the next natural step. So hopefully, if that's not super clear, be happy to answer any questions. But that's kind of what we're thinking about right now.
Okay, so it sounds like on a practical level, you're providing a toolkit, or what I find really interesting about what I think you're describing is that we're thinking about a new human computer interaction space. Am I getting it?
Yeah, I mean similar. Like if I had to describe what we're doing in one sentence, is explain what you want your function to do, and you'll just have that for you. So reduce the amount of actions you need in order for something to happen. Human actions. I mean, human actions as in going to ChatGPT, iterating, writing code, testing, all these different things. How can we reduce the amount of actions that it takes for a human to create an action? And by action, I mean, action can mean very many different things. In this context, it means an API call or an integration with an app, an SDK, like some way to bundle a lot of code, basically, or a lot of things that happen in the background.
Right. Okay, that makes sense to me. Yeah, and that leads on nicely into something else that I want to ask you about, which is the design process and how you go about designing agentic systems. Are there elements that you find significantly impact the effectiveness or make an AI agent work better?
Yeah. The biggest thing I would say, and maybe this will change over time, but specificity is very important. Meaning, if you try to create a general prompt that can do everything, it will end up doing nothing super well. And this is a big realization we had from benchmarking agents and our time integrating different agents. And one of the agents was the best on the benchmark until we started adding more tests. And tests on the benchmark means like practical things like, find this piece of information or format the spreadsheet in this way. Once you started adding more tests, the prompt was already many thousands of tokens to handle all the different cases that I may have to do, this general agent. But at a certain point, it started regressing. Every new line that you would add, and as well as I do, like even a line break changes completely the outcome of a prompt. It became pretty much impossible to prompt engineer something. The thing that we realized is that really a prompt is almost equivalent to one use case. And kind of expanding that out is like, if you want something done really, really well, do it with just one prompt. Don't have this like general thing that does everything. Have like experts, almost like experts that you can direct towards things, and this thing can do it really well. It's also a science. Like this is also I mean, like, what are the tricks? What are the tips? Like, I can like, there's very general things like how to prompt engineer and how to hook things up together, how to ask it to do actions. But ultimately, it's like it's a black box, right? And so it's a lot closer to biology than like traditional computer science, right? Where it's like, here's how you eke out a little bit of optimization from your C++ function. It's more like, okay, try it. Like maybe, maybe asking it, like telling it that your grandma's dead and you need help would actually be better. Or like, I don't know if you saw on Twitter recently, there's like this dog treat thing. Where it's like you say you're gonna give it dog treats. And like it's like with the data it's shown to perform better. So it's like, yeah, just like it's literally it's all experimentation. That's the beautiful thing about AI engineering. It's no longer limited to your technical expertise, your depth of expertise. It's limited to your creativity and willingness, obviously, which is a beautiful thing and why it's risen up so much. And I'm happy to talk more about this and expand on this also in our Discord. We also our GitHub repository is open source, so if anyone wanted to take a look at that, that's also open.
The experimentation is very, very cool. And yeah, here at Valory, we're also very big on open source. That's something that matters a lot to us. The next thing that I wanted to talk about is, have you seen someone else develop a truly autonomous agent? And if not, what elements do you think are missing for us to achieve that?
I mean, that would depend on the definition of truly autonomous, right? If the definition is the literal definition, which is like something that just like does stuff on its own, that exists. But again, it's like autonomous is like, is this actually an assistant? Is this at the level of a human? What type, like what specialty of human is it at? Like, is it at the level of an assistant that's been working in the field for 30 years? Like, let's just say emails, or is it someone who's new in the field, right? That you still need to give advice to. And it's a lot like right now as a whole, the field is closer to the first one, where the best it can do is like you give it some advice. It'll probably get things wrong usually. There's no way to know if it's going to get it right because even the prompts themselves, even at a temperature of 0, even at a seed of 0, they will change. Environments change. So there's no way to know that you can handle everything. So yeah, I mean, what's gonna lead to improvements? The obvious one is better language models. That's the very obvious one. The other is things that must be figured out, like RAG, like retrieval augmented generation, where essentially you figure out what is the correct thing to know. Like, how do you retrieve the correct thing to know? How our brain works is when you tell me something, when you give me some sort of speech, it goes into my Warnix area. So it hits my ears, they get processed. Then there's the Warnix area, which essentially combines the speech with it triggers emotions, it triggers thoughts, it triggers past experiences, and then it passes it on to the Broca's area. And the Broca's area actually generates the tokens, the speech that I'm saying, based on what the situation is in that I'm in right now, based on the question I'm responding to, based on the context, based on what I'm trying to get across. It generates the optimal string of speech for that. And RAG would essentially be that Warnix system, which is like how do you get the correct context in order to generate these things? And then language models are essentially going to be are this like Broca's area thing, which then takes all these things and figures out what is the best, given the goal, what is the best thing to say. The other thing is the parallel between like tokens per second and compute power. So when computers first rose, and even now, I mean, they're measured by clock speed, like how many operations per second can they do? And right now they're in the gigahertz, they're in the billions of operations. But they started from, tens and kilobytes and then megabytes, right? And it's very similar here, where the more throughput you have with tokens per second, the more you're able to process, the more you're able to think. I mean, you can imagine kind of a thinking process where for every input that comes in, you have 60 different prompts and you like verify it and you have like a graph of thought. Like there's all these like techniques that boost prompting 100%. They're just not practical because they cost a lot of money and they're slow. And so the other thing is tokens per second. So better language models, tokens per second, and RAG are probably the 3 biggest things that I would say.
Cool. You mentioned self-improvement, and that's something that I'm interested in. I wanted to ask how far along the path to a truly self-improving AI you think we are, and if we're not there yet, what steps would be needed for us to get there?
I could be wrong, but sooner than we think. I could be wrong. I'm any of this I'm saying, I'm not an expert, right? Like take everything I'm saying with a grain of salt. I tweeted about this recently actually. And this was during like the whole Q star debacle. So for those that don't know, there was on Twitter there was this whole like uproar for when OpenAI was they like hinted at some Q star thing, and people were thinking it's some sort of like self playing, like back to the world of reinforcement learning and deep learning or Q learning. And it reminded me of the Dota agent that OpenAI built back in 2019, I think it was, where the way the agent learned, and I think AlphaGo and the chess playing one before it as well, was through self gaming or self playing. So it would play earlier versions of itself, and there's like certain objective reward metrics, such as like winning, speed to winning, like leveling up, all these different things, like enemies killed, etc. for Dota. And through this, it was able to learn continuously and get to the point that it was at. Now, when we think about language models, what's the equivalent here? It's not pure language, because pure language is fuzzy and it's very subjective. But what is not is code. Code, there's a few objective evaluation metrics, like does it compile, does it produce an output, does it produce the correct output? And with these three metrics, you can produce verifiably good synthetic data and generate massive data sets and learn through self-play. Now, it won't really work with the current architectures with transformers, as far as I understand, just because online learning leads to like certain things like catastrophic forgetting, where the previous knowledge of the language model is forgotten, or some things in the previous weights are forgotten. But with architectures such as this one with Q learning, and again, I'm not an expert, so this is like my kind of high level view, it might be able to do that. And the biggest limitation to training these massive networks right now is tokens and how many tokens that you have. And there's this concept of training called chinchilla optimal, and it's just like I think Facebook discovered it. I might be wrong about that, but what is the optimal amount of tokens that you need in order to train a language model of a certain size? So I think at a 7 million parameter model, you need like 2 trillion tokens or something. I may be forgetting. It's around there. But right now we're training models that are of 500 billion, 2 trillion parameters, if you believe the leaks for GPT-4. And they're certainly not chinchilla optimal. And so how do you generate enough data so that you can actually make these chinchilla optimal? And, there's some, does it improve the model generally? Maybe, right? There's some research around coding improving the general capabilities of models. And so at least in the coding world, I think we could generate a lot of synthetic data. And from there, I think there could be some sort of boom that's imminent.
What do you think the next big capability unlock might be?
Yeah, I think this is probably similar to my answer from before in terms of like what's next, like larger language models, faster language models. We figure out RAG. I think those are the main things. I don't think context windows is actually a factor. It could be. I don't think it is. I think there's things that are more important than that. Evals are very, very crucial, and they may lead to breakthroughs in agents. Probably similar to like upcoming models. I agree with upcoming models.
Yeah, for sure. So lastly, do you want to make any predictions for the near-term future of AI agents or AI more generally? And I won't hold you to them.
Honestly, like in terms of predictions for the future, it's like there's some general things that I think are going to happen. I don't know when they're going to happen. I'm an
Or maybe,
optimist though.
yeah.
I always believe in the positive. I think I'd rather believe in like the positive side of things and be wrong than believe in the negative and be right. And it doesn't mean you don't be a realist. You believe in the positive and you think that you can get to the positive side, and then you handle the negative things that may come with that.
Yeah, that's a good attitude for actually getting yourself motivated enough to put in the effort that could create those good outcomes in the first place. You have to believe it's possible.
I also think humanity will benefit from AI like in an unparalleled way. So I have like we need to get we need like we like AI will help us in every single facet of our lives. From again, I think at the very start of this, I was like, yeah, like one of the reasons was like AI can help with everything. It's like once you get an AI that can explain things and can reason at a level above humans. And so it'll help us alleviate a lot of the things that we have right now and create something closer to a utopia, which we're already in a utopia compared to a millennia ago. But Life 3.0, like the first 15 pages of Life 3.0, those have been pretty by Max Tegmark. I like that view, and I hope we're all kind of striving towards not the exact implementation, but the outcome of that.
Yeah, I would agree with you. I do think we are going to see a lot of benefits, and I like that. I like the idea of that a lot. And I've also been asking people if they have any recommendations for our viewers who maybe want to learn more about AI agents or AI more generally, lectures, reading, learning pathways, people to follow, that kind of thing.
Yeah, I think there's Lillian Wang has a really good blog post. Andrew Karpathy and Jim Fan are the best follows on Twitter. And yeah, happy to answer any questions and ping me or join the Discord. Happy to help in any way.
Okay, great. So yeah, where can people keep up with you?
Twitter at Silen and AI, Silen and AI, and then the company is Stackwise, so at Stackwise AI.
Perfect. Okay, cool. Well, thank you, Silen. It's been a really interesting conversation, went in some unexpected directions that I think people are really going to get a lot out of it. So yeah, thank you for your time.
Yeah, of course. Yeah, thanks for having me.
So I hope you enjoyed my conversation with Silen today. To learn more about his projects, you can check out links in the description below. To learn more about Valory, our open source framework for co-owned AI, our projects, and our vision for the future of artificial intelligence, check us out at valory.xyz. Links are down in the description. Thank you for watching.